Right now, you feel like you're sitting still. Perhaps you're in a chair, holding your phone, or lying in bed. You feel a sense of absolute rest, but that is a profound cosmic illusion. In reality, you're a passenger on a planetary vessel screaming through the void at speeds that defy human comprehension. First, there is the rotation of the Earth, over 1,000 miles per hour. Then our orbit around the Sun, 67,000 miles per hour. But even that is just a local stroll. Our entire solar system is plunging through the Milky Way, and the Milky Way itself, it's not just drifting, it is being hunted. In the late 20th century, astronomers pointed their instruments at the cosmic microwave background, the afterglow of the Big Bang itself. They expected to see a uniform curtain of radiation. Instead, they found a terrifying discrepancy. One side of the sky appeared slightly hotter, while the other was colder. This wasn't a flaw in the universe, it was a Doppler shift. It was proof that our entire galaxy, along with everything in it, is racing toward a specific point in the dark at a staggering 1.4 million miles per hour. That's 600 kilometers per second. At this speed, you could cross the Atlantic Ocean in less than 10 seconds. But here is where the nightmare begins. When scientists turned their most powerful telescopes toward the coordinates of our destination, expecting to find a massive cluster of galaxies or a titan of gravity, they saw nothing. Or rather, they couldn't see anything at all. We are falling into a gravitational abyss, pulled by an invisible hand toward a region of space that seems to be intentionally hidden from our view. Scientists gave this invisible titan a name that has since become synonymous with cosmic dread: the Great Attractor. We know how fast we are falling. We know the direction of our certain doom. But the closer we look, the more we realize that something is fundamentally wrong with the map of our universe. We aren't just moving, we are being dragged. And the thing pulling the strings is lurking in the one place we are forbidden to look. Imagine trying to navigate a dark, foggy forest while wearing a blindfold that covers exactly 20% of your vision. No matter how much you turn your head, that black patch stays right in front of you, hiding whatever is lurking on the path ahead. This is the exact predicament of modern astronomy. We call it the zone of avoidance. The irony is cruel. The very thing that gives us life, our own galaxy, the Milky Way, is the very thing that prevents us from seeing our fate. We live inside a flattened disk of billions of stars, thick gas, and impenetrable cosmic dust. When we look up or down out of this disk, the view of the universe is crystal clear. But when we look toward the horizon of our own galaxy, we hit a wall. The center of the Milky Way is so crowded with stellar debris and light-blocking soot that it acts like a cosmic blackout curtain. And as if by some dark design, the Great Attractor is located precisely behind the thickest, most impenetrable part of this curtain. For decades, as we realized we were being pulled toward those coordinates, we were staring into a literal dead zone. We knew the monster was there because we could feel its gravity tugging at our heels, but to our optical telescopes, it was invisible. In the mid-20th century, this wasn't just a frustration, it was a crisis of knowledge. How can you prepare for a destination you cannot see? As technology advanced, we stopped relying on light that our eyes can perceive. We began to use X-rays and radio waves, frequencies that can slice through the dust of the Milky Way like a hot knife through butter. It was the cosmic equivalent of putting on infrared goggles in a pitch-black room. What we found when we finally peered through the zone of avoidance didn't provide the relief we expected. It wasn't just a large star or a lonely black hole. We discovered a massive, crowded graveyard of galaxies, all packed together in a region known as the Norma Cluster. But here is the chilling part. Even after accounting for the Norma Cluster and every visible galaxy in that direction, the math still didn't add up. The Norma Cluster is massive, yes, but it isn't nearly heavy enough to pull thousands of galaxies, including our own, with such violent speed. We had peeked behind the curtain, but the true master of our movement was still hiding in the shadows, far larger and far more terrifying than a mere cluster of galaxies. We realized that the Great Attractor wasn't a thing. It was just the tip of a structure so vast it defied our maps. By the 1980s, the scientific community could no longer ignore the tug. A group of 7 astronomers, later famously nicknamed the Seven Samurai, embarked on a mission that sounded like science fiction. They decided to map the flow of the entire local universe. They weren't just looking at where galaxies were, they were looking at where they were going. Using advanced statistical methods, they began to chart the velocities of hundreds of elliptical galaxies. What they found was a cosmic river. They expected to see galaxies drifting apart due to the expansion of the universe, like spots on an inflating balloon. Instead, they saw a massive, coordinated migration. Every galaxy within a radius of 200 million light-years was tilted toward the same mysterious coordinates. It was as if the universe had a downward slope, and we were all sliding toward the bottom of a gargantuan basin. This was the moment the term the Great Attractor was born. But as the 7 Samurai calculated the mass required to cause such a disturbance, the atmosphere in the labs turned from excitement to dread. To pull the Milky Way, a galaxy weighing as much as 1.5 trillion suns at 600 kilometers per second from such a distance, the Great Attractor had to be a titan. We are talking about the mass of tens of thousands of galaxies concentrated into a single region. Yet even as our X-ray telescopes finally penetrated the dust of the zone of avoidance, they found a paradox. They saw the Norma Cluster, and beyond it, the massive Caesar clusters. But even combined, all this visible matter only accounted for about 10% of the gravity we were feeling. This led to a terrifying realization that still haunts astrophysicists today. The Great Attractor might not be made of the stuff we see. Is it a massive concentration of dark matter? Or is it something even more exotic, a flaw in the fabric of space-time itself? The 7 Samurai had mapped the abyss, but they hadn't found the bottom. They realized that the Milky Way isn't just a lone traveler. We are part of a much larger, invisible hierarchy. And to understand what is truly pulling us, we have to look even further, past the boundaries of everything we thought we knew about our cosmic home. For decades, we thought we knew our place in the cosmos. We believed we lived in the Virgo Supercluster, a vast city of galaxies. But in 2014, a team of researchers led by Brent Tully at the University of Hawaii realized we were looking at the wrong map. They developed a new way to define our cosmic boundaries, not by where galaxies are, but by how they move. They discovered that we are part of a structure so immense it beggars the imagination. They named it Laniakea. In Hawaiian, the name means immeasurable heaven, and it is fitting. Laniakea is a cosmic watershed. Imagine a mountain range where the rain falls on 2 different sides. On one side, the water flows into one valley. On the other side, it flows into a different ocean. Laniakea is that valley for galaxies. It contains over 100,000 of them, spanning 500 million light-years across. And right at the very heart of this immense celestial valley lies the Great Attractor. We finally understood what the attractor actually is. It isn't a single plug or a hole, it is the gravitational center of our entire supercluster. It is the bottom of the basin where all the rivers of galaxies in our region of space are draining. Our Milky Way is just a single drop of water caught in a current that began billions of years ago. But as soon as we saw the full map of Laniakea, a new and even more disturbing mystery emerged. When you look at a map of a watershed on Earth, the water eventually reaches the sea. But in space, Laniakea itself, this entire immeasurable heaven containing 100,000 galaxies, is moving. The whole structure is drifting towards something even larger, something that makes the Great Attractor look like a minor anomaly. We finally understood what the attractor actually is. It isn't a single plug or a hole, it is the gravitational center of our entire supercluster. It is the bottom of the basin where all the rivers of galaxies in our region of space are draining. Our Milky Way is just a single drop of water caught in a current that began billions of years ago. As we mapped Laniakea, we realized that our immeasurable heaven was just a small suburb in a much more dangerous neighborhood. Beyond the Great Attractor, hidden even deeper in the cosmic fog, lies the Shapley concentration. This is the most massive structure in the observable universe. It is a gargantuan wall of over 8,000 galaxies, possessing the mass of 10,000 Milky Ways. If the Great Attractor is a whirlpool, Shapley is the ocean current that powers it. We are being pulled across a distance of 650 million light-years by a gravitational force so immense it shouldn't even exist according to some models of physics. But in 2017, the mystery took a terrifying turn. Scientists discovered that we weren't just being pulled, we were being pushed. On the exact opposite side of our path, in a region of space almost entirely devoid of matter, lies the dipole repeller. It is a colossal void, a localized nothingness that acts like a gravitational cannon. As this void expands, it effectively kicks our galaxy away, while the Shapley concentration pulls us in. We are caught in a cosmic vice, trapped between a massive wall of fire and an infinite cold vacuum. Yet even this push-pull dynamic doesn't explain everything. A team of astrophysicists led by Alexander Kashlinsky discovered something that broke the internet of the scientific world: the dark flow. They observed that certain galaxy clusters are moving at nearly 2 million miles per hour toward a point outside the boundaries of our observable universe. This motion isn't caused by anything inside our bubble. It's as if something massive, something located beyond the edge of the visible horizon, where light hasn't even had time to reach us since the Big Bang, is tugging at our reality. We are no longer talking about galaxies or clusters. We are talking about the possibility that our entire universe is being sucked toward a neighbor we cannot see. A leak in the fabric of space-time itself, where matter from our world is being drained into another. We aren't just moving toward a destination, we might be falling out of existence. The existence of the dark flow leads us to a terrifying frontier, the multiverse theory. Some cosmologists believe that the Great Attractor and the mysterious pull from beyond our horizon aren't caused by anything inside our universe. Instead, they might be bruises or scars left behind from a collision that happened at the very dawn of time. Imagine our universe as a soap bubble. Now imagine another bubble, another universe with its own laws of physics bumping into ours. That collision would create a permanent gravitational dent, a leak where our matter is being sucked toward the point of contact. If this is true, the Great Attractor isn't just a collection of galaxies, it is a cosmic drain, a tear in the fabric of our reality, where our world is slowly bleeding out into an infinite, unknown exterior. But what happens if we actually get there? What is the final fate of the Milky Way? For a long time, we believed in the Big Rip, the idea that dark energy would eventually win, stretching space so fast that we would never reach the attractor. We would be left in total isolation, a single galaxy in an infinite black void. However, new data from 2026 suggests a darker alternative. If dark energy fluctuates or weakens, gravity takes back the throne. This leads to the Big Crunch. Instead of expanding forever, the universe will begin to collapse. And the Great Attractor? That is the designated meeting point for the funeral of our sector of the cosmos. In this scenario, we aren't just drifting, we are participating in a multi-billion-year pileup. Thousands of galaxies, including our own, will eventually collide in a violent, chaotic crunch, merging into one titanic supermassive structure before being crushed back into a single point of infinite density. We are either destined for an eternal, lonely silence where every star fades into nothingness, or a final, fiery embrace at the heart of the Great Attractor. Either way, the immeasurable heaven we call home is on a one-way trip to its own destruction.